Hello everyone, I am Mayank and welcome to Simplilearn. Today, we will take you through a hands-off lab demo of how you can do time series forecasting using machine learning. Before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, do let us know in the chat section so that we can resolve them. Let's wait for some more minutes to let other people join. Let me tell you guys that we have regular updates on multiple technologies. If you are a tech geek in a continuous hunt for the latest technological trends, then subscribe to our YouTube channel and press that bell icon to never miss any update from Simplilearn. Great. I think we can get started. So in today's session, we will discuss what time series forecasting is. After that, a hands-off lab demo of how you can do time series forecasting using machine learning. We will perform different functions and different Python libraries for analyzing the data. Before we move on to the programming parts, let's discuss time series forecasting and proceed further for the same. What is time series forecasting? Making scientific projection based on the data with historical timestamps is known as time series forecasting. It entails creating models through historical study, using them to draw a conclusion and guide strategic decision making in the future. The fact that the future result is wholly unknown at the time of the task and can only be anticipated through analysis and evidence based priors is an essential distinction in forecasting. Give yourself a chance to Simplilearn's professional certificate program in AI and machine learning, which comes with completion certificate and in-depth knowledge of AI and machine learning. Check this course detail from the description box below. So here is one question for you guys. I will give you exactly 1 minute for this. You can comment or you can give your answer in the chat section so I can see if the answers given by you are right or wrong. Okay. So the question is, which type of programming does Python support? I'm repeating again. Which type of programming does Python support? Option A, object oriented programming. Option B, structured programming. Option C, functional programming. And option D, all of the above. So let us know in your answer in the chat section or in the comment section. So I'm starting a timer of 1 minute. Just type your answer in the comment section or in the chat section. Do let me know your answers, please. So I'm starting the timer of 1 minute. Which type of programming does Python support? Object oriented, structured programming, functional, or all of the above? Do let me know your answers, please. You can comment or you can give your answer in the chat section so I can see if the answers given by you are right or wrong. Which type of programming does Python support? Object oriented, structured, functional, or all of the above? 30 seconds remaining. Which type of programming does Python support? Object oriented, structured, functional, or all of the above? Let us know your answers in the chat section or in the comment section below. 10 seconds more. Which type of programming does Python support? 5 seconds more. So the allotted time is over. We will give a reply to those who gave the correct answer. And for those who didn't give the correct answer, we will give you reply with the correct answer. Okay. Now let's move to our programming part. So we will open command prompt to write a command to open Jupyter Notebook. So here I will write Jupyter Notebook. Press OK, Jupyter Notebook. Press enter. Will take time. It's open. So this is the landing page of Jupyter Notebook, and here I will select new Python kernel file. So this is how Jupyter kernel look like. So here, what we will do, we will import some major libraries of Python, which will help us in analyzing the data. Okay, import numpy as np. Okay, then import pandas as PD. Then import seaborn as SNS. The fourth one is from matplotlib port pyplot as PLT. Okay. Then we will import some model libraries. So here I will write from stats models dot tsa dot api import exponential smoothing and comma then simple xp smoothing. Then one more hold. We will write here import from sklearn dot linear underscore model import linear regression. Okay. Then import warnings. Warnings. Then we will write here warnings dot filter warnings. It should be ignore. Yes, there will be no error. Oh, it's still loading. Yeah. So NumPy. NumPy is a Python library used for working with arrays. It also has a function for working with the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for Numerical Python. Second is Panda. Pandas is a software library written for the Python programming language for data manipulation and analysis. In particular, it offers data structure and operations for manipulating numerical data and time series. Then Seaborn. An open source Python library based on Matplotlib is called Seaborn. It is utilized for data exploration and data visualization. With data frames and the pandas library, Seaborn function with ease. Matplotlib. For Python and its numerical extension NumPy, Matplotlib is a cross-platform data visualization and graphical charting package. As a result, it presents a strong open source substitute for Matplotlib. The APIs for Matplotlib allow programmers to incorporate graphs into GUI applications. Linear regression. The machine learning method regression built on linear supervised learning. Analysis regression is done. Regression creates a value for the aim prediction using independent variables as inputs. Its main goal is to investigate the relationship between factors and forecasting. Exponential smoothing. The exponential windows function is a general method for smoothing time series data known as exponential smoothing. It contrasts to the ordinary moving average, which weights previous data quality. Exponential function use weights that decrease exponentially with time. And there is one more simple exponential smoothing. The simple exponential smoothing classes use simple exponential smoothing models to give very simple time series analysis. A weight average of the most recent value and the preceding smooth value constitute the predicted value. The contribution of older value degrade exponentially as a result of the smoothing parameter. Okay, so after importing libraries, let's import dataset. For this, I will write here df or you can write data frame pd dot read underscore csv. Here I will write monthly underscore csv dot csv. Okay, this is my file name. You can download this file from the description box below. And for seeing the data, I will write here df dot head. Okay, then press enter. Yeah. So here PD is for pandas library, read is used for reading the dataset from the machine, and CSV is used for the type of file which you are using, okay, or which you want to read. And if you want to see the top 5 rows of your dataset, you can use head. And if you want to see the last 5 rows of your dataset, you can use tail instead of head. Okay, this one you can write here tail. So moving forward, let's see how many rows and columns are present in our dataset. For that, I have to write df dot shape. Okay, then press enter. Okay, it will give error. Why? Because this. Yeah. So here you can see 847 rows and 2 columns, date and price only. So moving forward, let's do some EDA, exploratory data analysis. Okay. For that, I have to write here print data date range of gold prices available from then here I have to give curly brackets, then df dot location loc, then colon comma date. Okay, D is capital here, so I have to write date. Then from location 0 to again same thing df dot loc date to the length of df minus 1. Oh, everything seems good. Yeah. Then press enter. Okay. We have date range of gold prices available from this 1950 to 2020. Okay, in our data set. Then here I will write date equals to pd dot date range start from slash 1 slash 1950 comma and equals to 8 slash 1 slash 2020 comma frequency equals to median. Okay, then here I will write date, then press enter. Yeah. So here you can see date time index. Okay, from starting till end, these dots, and here I will write df month was to date. Df dot drop is date, comma axis is 1, comma in place was to true. T should be capital. Okay. Then df equals to df dot set index and month, and df dot head, press enter. So instead of this date, we have adjusted this month, okay, for particular value. So moving forward, let's see the graph, different graphs, okay. df dot plot, then figure set should be equals to 20 comma 8, then plot dot title is like gold prices monthly since 1950 and onwards. Okay, title should be this. Then X label should be plt dot X label will be months. Then plt dot Y labels should be price. Then I will write here plt dot grid. Okay, press enter. Okay, title spelling, my bad, title. Okay, then press enter. Oh, Y label it is, sorry. Yeah, here you can see gold prices monthly since 1950 and onwards. Okay, till from 1950 and from till 2020. Okay, this is the price. Then moving forward, let's see another graph. So I will write here for that round df dot describe comma 3. And here you can see the count variable and the average is 416.557 standard deviation. That minimum price value is this, 20% this, and the maximum value is this. Okay, so so the average gold price in last 70 years is this 416.557. Okay, only 25% of the time the gold price is above 447. The highest gold price ever touched is this one, 1840, 807. So we will do visual analysis. So here I will write AX equals to PLT dot subplots. Okay. Then figure size equals to 25 comma art. Okay. Then SNS dot box plot is X equals to df dot index dot year comma y equals to df dot values colon comma 0 comma ax equals to ax. Okay, then same plt dot title gold price monthly 1950 converts. Same graph will come, but in the different format. Okay. Let me remove this. Then plt dot x label must be year. Plt dot y label price, and plt dot x ticks will be rotation equals to, okay, I will give rotation 90. Plt dot grid. Can write here instead of grid, I can write here directly show. So grid is this format, this box format. Okay. So press enter. It's loading. Yeah. So here you can see from 1950, every year is here till 2020. So how the gold prices are decreasing and increasing. Okay. Let's see the another graph. I will write here from ads models dot graphics dot TSA plots quote month plot. Okay. Then I will write here figure comma ax equals to, then plt dot subplots figure size equals to 22 comma 8. Okay. Then month plot df comma y label equals to gold price. Okay. Comma, then ax equals to ax, and I will give the title plt dot title. So I will copy from here. Okay. And plt dot x label month, and plt dot y label be price. Plt dot grid. So here you can see gold prices monthly since 1950, like for every month, like January, February, March, April, so on till December. Okay. We will cover one more graph. Okay. And many more graphs. So we will go with the next graph. For that, I will write here. Let's go, comma, ax equals to plt dot subplots, and figure size equals to 22 comma 8. Then same sns dot boxplot x equals to df dot index dot month name. Okay, then y equals to df dot values, comma 0, comma ax equals to ax. Okay, then plt dot title, will put same title so I can copy from it here. Let's copy from here and paste it here. Okay, and plt dot x label, and plt dot y label, price, and plt dot grid. Okay, plt dot show. This time let's not use grid. Okay, okay, something pdf month name. Yes, you can see for every month. This is another type of graph. Okay, box plot graph. So why we are creating so much graphs? Because we are doing EDA, exploratory data analysis. In this, we have to see the multiple different types of graph. Okay, so moving forward, let's see average gold price per year, like trend since 1950. So for that, I have to write here df underscore yearly underscore sum equals to df dot resample sample, then a dot mean df underscore yearly underscore sum dot plot plt dot title, and here I will write average gold price yearly since 1950, or you can write onwards, from onwards 1950. So here I will write plt dot x label year and plt dot y label price. Okay, then plt dot grid, this time we'll use grid. So here you can see the average gold price yearly since 1950. Okay, this is the chart till 2020, like sometimes up, sometimes down. Okay, and we will see now like average gold price per quarter, like trends, like since 1950. So here I will write df dot, not dot, df dot quarterly. Okay, underscore sum equals to df dot resample quarter q dot mean. Okay, okay, move this. Then df underscore quarterly score sum dot plot. Then the same plt dot title from here. Here I will write average gold price quarterly. Quarterly. Okay, since 1950. Then plt dot x label is now here quarter. Plt dot y label is price. Okay. Now plt dot show it this time. Okay, df underscore quarterly. Okay, quarterly. Yeah. So here you can see the price prediction. Okay, let me set to the grid only. It's not visuals are not good. So grid. Yeah. So here you can see the quarterly prices prediction. Okay, average gold price quarterly prediction. So like moving forward, we will see now average gold price per decade, like per 10 years. Okay, so from 1950 only. So here I will write df underscore decade underscore sum equals to df dot resample every 10 year. Okay, 10 year dot mean. We are writing mean because we are like putting out average. Okay, so df underscore decade underscore sum dot plot plt dot title average gold price per decade since 1950. Okay, it's since 1950. Yeah, perfect. So here I will get plt dot x label, then decade is of like every 10 year. Plt dot y label and plt dot grid. Yeah. So here you can see the average gold price per decade, like from 1950 to 1960, like this, straight, then again straight, then up, then sometimes down, then up and down. Okay. Every 10 year, you can see a 1990, 2000, 2010, and 2020. So moving forward, let's do like analysis in coefficient of variation. The coefficient of variation CV is a statistical measure of the relative dispersion of data points in a data series around the mean. And in finance, the coefficient of variation allows investor to determine how much volatility or risk is assumed in comparison of the amount, like amount to the return expected from investors. Okay, the lower the ratio of the standard deviation to mean return, the better risk return trade off. Okay, let us look now the CV values for each year in gold prices. So CV means coefficient of variation in prices. Okay, so here I will write df underscore 1 equals to df dot group by df dot index dot year dot mean dot name columns equals to I will write price and mean. Okay. Then again df underscore 1 equals to df underscore 1 dot range, or what we can do instead of range we can write merge df dot group by scope df dot index dot year, or then the deviation, rename columns equals to price, then the deviation, comma left index equals to true, then comma right index equals to true. Okay. And here df underscore 1 scope equals to df underscore 1, then the deviation slash df underscore 1 into 100, like dot round figure should be like 2 after decimal, how much like numbers you want to see, then df underscore 1 dot head, press enter. Yeah, so here you can see for every year I have mean, standard deviation, and this coefficient of variation. Okay, for every year. So like moving forward, let's see the average gold price per year again. So for that figure underscore figure dot comma ax equals to plt dot subplots figure size 15 comma 10. Okay. Then I will write here df underscore 1 is like cov underscore dot plot plt dot title average gold price yearly since 1950. Okay, then plt dot x label is year, or plt dot y label coefficient of variation, I'm writing cv in percent. Okay, then plt dot show. Get df underscore invalid syntax. Okay, what I COEC is capital ECT get dot plot. Okay, CO df underscore one df underscore one. Right, okay, it here. Valid syntax. Okay. So here you can see average gold price since 1950. Okay. This is like percentage, CV in percent. Okay. Like good, you can say the chart. So the CV value reached its highest in 1978, like somewhere here, like 1980, 1978. Okay. Like near to 25%, which could have made the asset as a highly risky. But in 2020, the CV value is closer to 5%, which makes the asset variable via good investment. Okay. So now what we will do time series forecasting. Okay. We will train model, we will build model, different model. We will train and test split to build time series forecasting model. So for that, let me do like this first. Yeah. So here I will write train equals to df dot index dot per year. Okay, equals to 2015. And for the testing, we will write df dot index dot year 2015. Okay, for training we are taking till 2015, for the testing we are taking till 2020 from 2015. Okay, then I will write here how many columns present in train or test. So for that I will write print train dot shape and print test dot shape. Press enter. 792 rows and one column in training for training the model and 55 to test the model. Okay. So now let's see the training data and testing data. So train is like square brackets. So price dot plot, then figure size equals to 13 comma 5, and font size should be equals to 15. Test size dot plot figure size. Let me give same 13 comma 5, and font size should be same 15. Okay, then plt dot, let me add grid, plt dot grid, then plt dot legend training data, comma, test data. Okay, then plt or show. I will tell you what the legend is. Okay, so here you can see the training data in blue and the testing data. Okay, this is known as the legend, this portion. And yeah, so here you can see month wise. Okay, till 2020 and from 1950, right? These are the prices and this is the chart. So moving forward, let's do model formation now. Okay, we will do two models, linear linear regression and the naive Bayes one. Okay, so first we will go from linear regression. For that, I will write train underscore time equals to I plus 1 for I in range train. Test underscore time equals to I plus length like train one for I in range, then length should be test. Okay, so for length, training time comma length should be test time. Present. Okay, this is the training and this for the testing. 792 rows and here 55 rows in testing. So LR underscore LR means linear regression. Let me make it capital. Train equals to make a copy LR underscore test equals to test copy dot copy. Then LR, okay. So LR train time equals to train time. Okay. And LR underscore test time equals to test time. Okay, underscore is there. Yeah. So here I will write LR equals to linear regression dot fit to the model was LR train, and for the time LR LR underscore train price values. Linear regression is not defined. Okay, my bad. L should be capital. Yeah. So now see the graph. So test underscore prediction underscore model 1 equals to lr dot predict lr underscore test time lr underscore test cost equals to test underscore predictions score model 1. Okay, let's create the graph figure size should be to 14,6 plt dot plot train price comma label should be train. Okay, then plot plt dot plot test price label equals to test plt dot plot then lr train or tests forecast label equals to regression on time. Okay, regression on time. Then again plt dot legend loc equals to best plt dot grid enter. Okay, here I have to write predict loading. One more error. Price. Just price. Okay, is the price. So here you can see regression on time test data is this green one and this training data and the testing data. Okay, let's find the map now. So for this, we'll write here def map actual comma prediction then return count p dot mean abs actual prediction actual by 100 comma 2. Okay, forgot to give the yeah. So for getting the map, you have to write a map underscore model underscore test equals to map test price dot values comma test underscore section underscore model 1. Okay, then print is percent 3 dot 3 f. Then here I put percent ape model 1 underscore test comma percentage. Press enter. Test. Okay. Actual is not defined. Map test. Model 1 test. Map test. Values. The test sections. Model 1. Okay. Here A is small. So map here you can see 29.760. So you are a bit confused, like what is MAP? MAP is a measure of prediction of accuracy of a forecasting method in statistical model. Okay, is a measure of prediction accuracy of forecasting method in statistical method. Okay. And now results equals to pd dot data frame test MAP in percent MAP underscore model 1 comma index equals to regression on time. Okay, then I will print the results. Okay, D should be capital. Module pandas has no attribute data frame. Okay. Model 1 is not defined. Let's go test. Well, it's in there. Perhaps you got to forget a comma. Colon. Model 1. Okay. Here you can see the test map, regression on time. So let's do with the name now. We have to perform the same pattern. So what I will do, I will write the code and get back to you. Okay. So I'm done with the code. So here you can see I have same pattern, train and test copy. And this is the name forecast on the test data. So this is the line and this is the training and this orange one is testing. The same we have got map like 19.380. Okay, so and regression is this, the name model. So what we will do, we will create now final model of ours. Okay, and we will forecast, final forecasting we'll do. For that I have to write final model equals to exponential smoothing. Okay, df comma trend equals to additive comma seasonal equals to additive comma fit smoothing level equals to zero point 0.4 comma smoothing trend equals to zero point 0.3 comma smoothing seasonal equals to zero point 0.6. Okay, press enter. Exponential. So map go final underscore model is equals to map like df price dot values comma final underscore model dot fitted values. Okay, then print map comma map underscore final underscore model. Okay, so map is 17.24, which is quite good for the final model. Okay, so getting the prediction for the same number of timestamps at the present time in the test data. So I will write here predictions equals to final underscore model dot forecast steps equals to length dot test center. Now we will compute 95% of confidence interval for the predicted value. So TKF equals to PD dot data frames data, then lower CI prediction 1.96 into NP dot standard deviation of final model dot 1. Okay, and comma right here prediction Okay, then upper CI prediction plus 1.96 into dot standard deviation the same final model dot so 1. Okay, then prediction underscore df dot at. Okay, so this is lower CI prediction and the upper CI. Okay, how much it will forecast or now at the end at the final state what we will do, we will plot a graph. Okay, forecast graph along with the confidence band. So for that, x is equals to df dot plot label equals to actual comma figure size 16 comma 9 prediction df dot plot ax equals to this comma label underscore df, it's lower CI. What I will do instead of this label equals to forecast comma alpha equals to 0.5. Okay, this dot fill between function underscore df dot index comma prediction underscore df lower underscore ci comma prediction underscore df this ci. Okay, then color equals to m comma alpha equals to 0.15. Okay, then axis dot set underscore x label year month. Okay, axis dot set y label is plt dot legend should be location equals to best. Then plt dot grid plt dot show. Okay, this is plt only. Then press enter. Okay, 16 comma 9 positional argument follows keyword argument. Okay, right, 15. Oh, okay, okay. I have to give you another upper CI. I've read upper CI. So here you can see our final model forecasting. So till 2020 it is showing like normal, and after that till 2030, okay, this will be the forecast as per the data. Okay, so here you can see, we have the map is 17.24. Okay, then here I did the prediction for the testing data, and here I created the data frames. These are the data frames, lower CI prediction and upper CI, and then I have created the then I have created the final graph of the forecasting. Okay, so I hope you guys must have understood like how you can do time series forecasting using machine learning or Python. Like if you have any queries, you can ask in the comment section. Our team will respond you as soon as possible. Or if you want full code, this full code, just comment down for the same. And you can download the dataset from the description box below. And don't forget to check the course link from the description box below, AI and machine learning. Thank you so much for being here. If you enjoyed this video, please subscribe to our YouTube channel and give a like to this video. Thank you and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.